In number 7 in the lecture examples, it wants us to calculate the solubility in grams per liter of silver fluoride, given that Ksp equals 1.8 times 10 to the minus 14th. So we need to examine when silver fluoride dissociates, it's going to make silver ion and fluoride ion. Then your Ksp expression is going to equal the concentration of silver ion times the concentration of fluoride ion. That would be over 1 because this guy's a solid, so it doesn't get included in equilibrium expressions. And so that means, since these guys are going to be both X, right? If X amount of silver fluoride dissolves, you'd get X amount of silver ion, X amount of fluoride ion. So you can substitute X and put it in there. So you end up with Ksp equals X times X, or X squared. We can grab our 1.8. So it ends up 1.8 times 10 to the negative, I wrote that down right. It should be to the negative 8th. My bad. All right, so 1.8 times 10 to the negative 8 equals X squared, where X represents the molar solubility. So we'll take the square root of each side, and that ends up with X equals 1.34 times 10 to the minus 4th. Since that's going to equal our molar solubility, that's in moles per 1 liter. So then to get to grams per liter, I need to convert moles to grams. So we're going to take that times silver fluoride. If you look on a periodic table, silver is 107.87. Fluoride, it just depends on if it's charged, is 19. So you add those together and it's 126.87 grams for every 1 mole. So you multiply those together, you'll get grams over liters. And I guess this guy was only 2 sig figs to start with, so we'll round our answer to 0.017 grams per liter. And then I'm going to go ahead work out number 8. Number 8 is the exact same process backwards. So number 8, solubility of strontium sulfate is 0.16 grams per liter. What's the solubility product constant? So it wants us to find, can you see that? Ksp given its solubility in grams per liter. The substance is strontium sulfate, which it's going to dissociate, same deal, into 2 ions, strontium 2 plus and sulfate 2 minus. So it just ends up being X and X. So Ksp is going to equal X squared, where X equals the molar solubility. So first we got to convert that 0.16 grams for every 1 liter to the molar solubility. And then we're going to plug it in for X. So we'll take the molar solubility, square it, and then that will equal our Ksp. So times, and then it's 1 mole of strontium sulfate for every however many grams. Sulfur's 32.06, oxygen 16.00, strontium it's like 86, 87 out. But strontium sulfate, 1 mole of it weighs 183.68 grams. So those divide away and you end up with a molar solubility of 8.71 times 10 to the negative 4th moles per liter. And you plug that in for X, So it's going to be 8.71 times 10 to the minus fourth squared. And so we get a value for Ksp that should be 7.6 times 10 to the minus seventh. The label on Ksp, just like KEQ, there isn't one. So it's just that numerical value.